In this video, we're going to look at solving a linear inequality in one variable. So what we're going to be looking at are a range of answers or an infinite number of answers. For example, if I say x equals 3, we know if we look at the number line and write in 3 that that is the only answer. But when we look at x is greater than 3, let's say greater than or equal to 3, we have more than just one answer. Again, we'll start out at 3 and we'll include 3, but we know that all values of x are going to be greater than 3. So 4, 5, 3 billion, 18 zillion are all possible answers to make this problem correct or true. So before we actually get to solving these equations, let's talk a little bit about how we would write them. So I'm going to delete all this. And I'm going to be a little more specific this time. So I'm going to do a couple of examples. We're going to do x is greater than 2 and x is greater than or equal to 2. And I want to represent these or show you these in a couple of ways. This is just simply an inequality. Well, we can also do a graph. So we can specify the pivot point, which is 2, and we know that x is going to be greater than 2. So we know that, we don't know how it's going to handle at 2, but we know that we're going to get more values greater than 2. But how do we handle that 2? In this particular example, 2 is not part of the solution, so we will use an open circle. We could also, I'll draw the same graph, do number 2. Again, we'll still have the same range, I just squiggle it in there. But instead of using an open circle or later a closed circle, we're going to use either a parenthesis or a bracket. So in this instance, we'll use a parenthesis to identify what do we take into consideration with the 2. So in this instance, a parenthesis means don't include 2. So now if we do the next one, same point, we know that the data is going to be to the right of that, so all those values. But this time we're going to use a filled in circle. Just fill that in. Well, sometimes that works. Some books use that. Another option is to use a bracket. So again, I'm going to identify 2, the range of data to the right, but instead of using a parenthesis like I used in the previous example, I'm going to use a bracket. And notice that both the bracket and the parenthesis point to the data. So let's do another one. Let's say x is less than 8. I will say less than negative 8. So we can do our number line, identify negative 8. We know that values have to be to the right of 8, but we'll either use an open circle or a parenthesis pointing to the left. And in this instance, it points to the left. That includes all the data. And then one last example, x is less than or equal to negative 8. So same point, same data, but instead we're going to use a bracket. So by graphing, we can get an idea, a sort of a picture of what the data is going to look like. A last method is to use interval notation. And what interval notation says is to identify the left and the right bounding, and then either use a parenthesis or a bracket to tell me whether or not to include that. So for this first one, x is greater than 2, we know that we're going to put it up like 2, comma, infinity. Meaning the leftmost bounding point is 2, and the rightmost bounding point is infinity. Now we don't want to include 2, so we'll use a parenthesis. And we can never get to infinity, so we'll also use a parenthesis. In this next one, the two extremes, or the boundary, are again 2 and infinity. We know that when we go to infinity, just like Buzz Lightyear, infinity and to beyond, we can never get to infinity. So on the left bounding, we want to include 2. So we'll use a bracket. In this third example, x is less than -8, we know that our right range is from minus infinity. And I'm sorry, that was the left. And then the right is -8. As before, we can't include infinity, so we'll use an open parenthesis. And since we know we don't want to include 8, we'll also use an open parenthesis. So remember, an open parenthesis, whether it's left or right, tells you that you're not including the point. And then the last one, again, minus infinity, comes in from the left. -8 is the bounding, but we're going to use a bracket. If I gave you an example, let's say parenthesis -6, comma, 15, bracket, we can write this and we can plot this on the number line. So -6 and 15. The left bounding is 6, and since we're not including that, since we used a parenthesis, we'll just use the open parenthesis. And then the 15, we want to include it. So we'll put a bracket there. And then all we have to do is shade that in. And that tells us our value is between -6 and 15. So this is where we can graph linear inequalities in one variable. We use a number line, and we can either use an open circle or a closed circle, or we could use parentheses when we don't want to include that point in our range, or we can use brackets when, yes, we want to include that. I hope this is helpful.